We're going to take a look at the rules and properties of exponents. Separately, each of them by itself is not too bad, but we're going to have to know how to use each of these rules once they get all combined into the same problem together. So the first one is a product of powers. So that's when you're multiplying the bases, because that's what product means. So say you had the example x to the fourth times x squared. When you have a product of powers, you add the exponents. So you would multiply the numbers in the front. So really this is a 1 times 1. So you get 1, add the exponents, 4 plus 2 is 6. And we can actually, 4 plus 2. So you would multiply the coefficients, but we're adding those exponents. So when it comes to what we have to figure out to do with the exponents, that's how you would write that. So what if we have a power raised to another power? When you have a power raised to another power, you distribute the power inside of the parentheses. So we distribute, if we had x squared to the third, the 3 inside of the squared, and this becomes x to the 6th. So power of a product, you distribute the value inside to everything inside, or distribute the value outside to everything inside. So it's very similar to what we just did in that second rule. It's just that if there's more than one thing inside the parentheses, we're distributing that power to everything inside. So really, even though you don't see it, those are powers of 1. So when we distribute that in there, 1 times 5, 1 times 5, we get x to the 5th and y to the 5th. So the x and y are really kind of separate. They both have their own power, and the 5 goes to both of them. We're going to go, well, we'll just do negative exponents. So for negative exponents, they're really the inverse is what they would call. If you saw a negative power, it would be the inverse or opposite. But we're not allowed to have negative powers in our simplified or final answer. So really all we have to remember is that if we have a negative exponent, we literally need to move it from wherever it is. So if it's in the numerator and it's negative, moving it to the denominator will make it positive. Vice versa. If you have a negative power in the denominator, moving it to the numerator will make it positive. So say you guys had x to the negative 6th. This is really x over 1, but you need to move that to the bottom to make this x to the positive 6th. If we need a fraction, we would just put 1 over. Let me give you guys another example. So say you had 3x squared y to the negative 4th over w cubed z to the negative 2nd. Okay, we've got a y and a z with negative exponents. So we're not moving the whole top to the bottom or the whole bottom to the top. It's just the part with the negative power. So just the expression or term with the negative power is what needs moved. So the z will come to the top with the 3 and the x and now be a positive squared value. The y will go to the bottom with the w and be positive. You really do simply just move any negative exponents to make them positive. Okay, let's do quotient powers and then we'll go back and look at 0. Exponents. So quotient powers. Quotient is just the mathematical term for division, fraction. So when we multiply numbers together like we did up here, when we're multiplying two terms together, we add the exponents. So when we divide two values, we subtract. So x to the fifth over x squared would become x to whatever 5 minus 2 is. So x to the third. And you want to be careful with this. I think it trips people up sometimes. You always want to do numerator minus denominator. So top minus bottom. So for instance, let me give you guys another example. Say I gave you x to the fourth. Now I'm going to do negative 4 over y squared x to the negative 2. Okay, the y is just going to stay. But what do we do with the x's? We need to subtract them. They have all these negatives. You guys would do negative 4 minus negative 2. That becomes a plus 2. So negative 4 plus 2 makes this x to the negative second over y squared. But that x power is still negative. But I want you guys to understand that when we subtract these powers, the term is always going to be in the top unless we need afterwards, we need to move it. So in this case, we would need to move that x squared down to the bottom to make it positive. But you always want to do the numerator or the top minus the denominator, and we're going to keep it in the numerator of the fraction unless it needs moved. So that's really the trickiest rule, I think, to understand, especially if we have negative powers. Okay, so zero exponents. If you ever have anything to the zero power, it always equals 1, no matter what. It could be 500,033,810, so the zero power is going to equal 1. You can even type it in your calculator to try it out. But what happens if you think about the quotient rule we just did? Say we had n to the 6th over n to the 6th. Well, we would subtract those powers and get n to the 0. Okay, it seems a little weird that something to the 0 power would be 1, but we started with something over itself. Anything over itself is always equivalent to 1. So, anytime something is raised to the 0 power, it is always going to equal the value 1. And the last rule is the power of a quotient. So same thing, anytime you have something outside the parentheses, you want to distribute it inside there to everything inside. So this would become x cubed over y cubed. You multiply that power inside there.